Hello friends, in last OOPS concept, I have discussed about objects, classes, abstraction and inheritance. Now, in today's session, I am going to explain about this polymorphism and encapsulation. So let's get started with the polymorphism. So what is polymorphism? Polymorphism is nothing but many shapes. Like poly means many and morphism means shape. It means in programming language we have one function which perform different activities, different behavior. So polymorphism is of like polymorphism refers to many forms. It is a process that perform a single action in different ways. It occurs when we have many classes related to each other by inheritance. Polymorphism is of two different types, that is compile time polymorphism and runtime polymorphism. One of the example of compile time polymorphism is that when we overload all static method in Java, and runtime polymorphism also called a dynamic method. So the another name of compile time polymorphism is early binding, and runtime it's late binding. Why it is early binding? Since at the compile time, like it knows like whatever is initialization, and at the runtime polymorphism or late binding, it means once we run the program, then we will able to find out which is what is the behavior of that particular function and behavior like that property. So, for example, there is a class which is bird, right? And bird having a sound like bird sound, it is going to print, and this is the end of this sound sound function. This is the end of this sound. Now, and this is the end of this bird class. This is the end of this bird class sound function. So it means there is a bird class which is having a function sound, and sound is going to print bird sounds. Now we have another class that is pigeon, which extend this bird, which inherit this bird class, and which is override basically the sound function of this bird and print its own behavior, how the pigeon sound is. It is cooing. And there is another bird that is sparrow, which also extend bird, and its sound is chip. So what these two are going here, it is going to override the function of this bird. And did you notice like what kind of inheritance it is having? It extend bird, it extend bird, like pigeon and sparrow, they all inherit this bird. So this is nothing but a hierarchical inheritance. Hierarchical inherit. So I hope you understood till now. Now, in above example, we can see that common action sound, but there are different ways to do the same action. Like sound is the same in both, but different action like chip and queuing. This is the this is the this is what we call polymorphism. Polymorphism in Java that I have already told to you. It's a static and compile time and dynamic and runtime. Static also known as early binding, and It is late binding. So here I am going to describe what is compile time polymorphism in Java. Compile time polymorphism in Java is also known as static, that we have already knows, to resolve at compile time, which is achieved before through the method overloading. Compile time polymorphism is that the system knows what is going to be performed. This is compile time. Runtime polymorphism is dynamic binding. Here, the system does not know what is going to perform at the compile time. The system knows what is performing while running that program. So this is what a runtime polymorphism and dynamic binding. Now I'm going to start what is encapsulation. Encapsulation is like same as capsule, like same as capsule, which is comprised of medicine, right? So the main example of caps like encapsulation is class. Class is the combination of data method, data members, and all other are. So class is a capsule, that is encapsulation. So it is a process. Encapsulation is a process that binds together the data and code into the single unit. So class is nothing, it's a single unit which is binds data member and data into one unit into one single unit. It is also known as a in this process, data is hidden from the other class and can be accessed only through the current class method. It is a one of the definition of it. Encapsulation acts as a protective wrapper. It's basically wrapper that prevent the code of data being accessed by the outsider. Yes, like class is the wrapper, right? And we can make that class public, private, protected to being accessed by the outsiders. So how we gonna achieve this encapsulation? We have this example. Here there is a class animal. In that class we have a private int age. In that class we have one function, that is get age, which is going to return age, and this is the end of get age. We have another method, that is set age, which is going to set this dot age. What is this? What is this here? This is like, for this particular class, it is going to refer, like this dot age is refer by this class age int, like int variable, age variable. For this means currently what is going to be accessed. Now we have main class. Now we have main class, where it is going to create one object of animal, one object of this class animal, and going to set age as 12. Set what this set is going to perform? It is going to set the age as 12. So set age is this one. So 12 is going to perform from here, and it is going to set this dot age. This dot age is nothing, it's a private variable, that is age. It is going to initialize with 12. Now get age is return age. So here a1 dot set this object called set age, right? 12. It is going to set the variable age as 12, and animal age is a1 dot get age. It is going to be print 12. So this is what the value is. So what we understood about This encapsulation here is that encapsulation is a wrapper of variables and class, and this is going to be performed for like the how we can access, how the other class, other object can access that class. So thank you guys for this.